Assalamu alaikum warahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. Alright. Just making sure everything is fine. Gotta share the stream. Let's go. Alright. Okay. Hello, Omar. Welcome to the stream. Welcome. Alright, just gotta wait a bit for people to join in. Hello, Al Rashdan. Hopefully I spelled your name right. Welcome back. I do remember you from the last live stream. That was an interesting stream. Yeah. Okay. Everything seems fine. Just gotta share the live stream. Probably. There you go. Just gonna shame myself today with my C++ skills and CMake skills, but whatever. So to be clear, this live stream will be just an experiment. This project, just like most of my projects, just an experiment. No expert at this subject, but we're gonna look into it. I did indeed try a lot of stuff, and I'm gonna share with you some of the knowledge that I've got the hard way. Okay, amazing. I think we're good to go. Right, so let's fire up C-line. Okay. Alright. For some reason the chat of OBS is broken, so I gotta use the browser's chat. Hold on a second. Okay. Okay. Let's go. Yo, what? That's super weird. Yo, what? You cannot. Weird. Anyway, just gotta get this the chat like this, like that. Okay. So right now we're all good to go, I believe. Okay, so I've been doing some crazy stuff. But yeah, we're gonna start from scratch, of course, as always. So C++ 23, C++ executable. Not sure what to call the project. I guess Modern Vulcan projects. I guess Modern Vulcan project, or maybe Modern CPP Vulcan project, whatever. Okay, so let's create the project and let's get started. Okay, so of course we gotta start with the project structure and CMake. Just gotta allow the Microsoft Defender so it doesn't degrade my performance with the project. Okay, nice. Okay, now let's change this stuff a bit. So let's create a source directory. Let's create a build directory. By the way, this is not going to be necessarily a tutorial. I'm not going to be explaining every single bit as I go. It's like just like a kind of a coding live stream in some sense, but yeah. Of course, I'm going to be trying to explain a bit about what I'm doing, but you got the point. Anyway. So we have source, and also we need third party. Yeah, okay, nice. Now I'm gonna put my main.cpp inside source, and I'm also gonna need the git ignore file dot git ignore, and I'm basically going to ignore the build directory, which basically contains my my CMake build stuff. Okay, you can use whatever IDE you want, but I prefer C-Line because it makes a lot of stuff much easier. I'm gonna be using Clank, I guess. Usually I use MinGW, so this is gonna be a little strange to me, but I'm gonna be using Clank, so I make sure that because Clank is cross-platform, while Visual Studio you can only use it in Windows, and GCC you can use MinGW in Windows, but GCC is usually best in Linux. So, but Clank is basically cross-platform or all platforms, so I'm gonna be using Clank. Although I'm not sure about debugging capabilities, honestly. I'm going to try to, you know, support all compilers if possible, but yeah. We'll see how it goes anyway. I'm using Ninja for the generator. Doesn't really make much difference. Okay, and I have all these builds: debug, release, release with debug info, and minimum size release. I have had many issues with C-Line a year ago. Int main return 0 is apparently an error back then. Yeah, there is like no IDE is perfect, you know. It's like software nowadays is just so broken, but yeah. Not a compiler error, but syntax highlight. Yeah. I did have one syntax highlighting issue, but it was with the C++23 ranges and views. So like there was some perfectly what I can say, like perfectly working syntax on C++23, but it was showing it as an error. But I think that's because I'm using the embedded engine for syntax highlighting. But whatever, anyway. Apply, okay. Although I like using latest features of C++23, but I'm gonna try to just stick with what Clank supports, which is usually not the most up to date. Usually Clank is kind of slow in supporting new features. For example, zip, which is quite useful. The zip view range thing is not supported currently in Clank, but whatever. So okay, nice. Let's go third party. Okay, amazing. I like to use the modern syntax, which is auto main int like this. I'm just gonna leave it like this to be consistent with other stuff. What's going on? Oops, I forgot this guy. All right, I'm just gonna return success. And all right, amazing. So let's go to CMake list. Well, we're gonna have some CMake list here in third party and in source too. CMake list. We gotta go with the modern CMake stuff. So let's have a CMake list in every directory. So here, let's go. Okay, I'm going to get this add executable, put it inside, and also I don't need this guy. I'm gonna put this inside of source, and I'm gonna call this source. You can call it whatever you want, doesn't matter really. And now I don't need to do this guy, just main.cpp. Yeah. All right, well, what's next? Let's see. Here I'm also gonna have a target called add library, sorry, and I'm gonna call this third party. And this would be an interface, because this one is not going to be a library by itself. It's just going to be an interface to like a group of libraries, basically. You're going to see how it goes, but yeah. All right, nice. Let's add subdirectories now. Add subdirectory, let's add the source, and let's add the third party, and then let's basically link them together. how it goes. Yeah, target link libraries. I'm going to link source, which is our executable, privately to third party. Since our target source doesn't really, like, nothing depends on it, it doesn't really matter if you use private or public or whatever, but I just use private anyway in this case. But anyway, whatever. So this should be all good to go. Now gotta do some craziness here. So target compile features, source, and here I'm gonna say private, yeah, cxx std23. Here you can basically tell it which standard, which C++ standard for this particular target for our own executable. On the other hand, the one that was before here, like set, CMake, you know, CXX standard here, this is global on all targets, but I don't like to use global stuff for Modern CMake nonetheless. But anyway, so that's target compile features. Next up is set target properties, I believe, source. Properties, CXX extensions. I'm gonna turn off the compiler extension, so I make sure that I'm not using some kind of C++ extension that belongs to some particular compiler, basically. That's the first one. Second one, I believe, is, I don't really remember what I wanted. Oh yeah, standard required. For now, I'm just gonna require the standard, so it wouldn't build or generate, should I say, if the standard 23 doesn't exist. But anyway, that's set target properties. What else? I also would like to go with target options. Now, if MSVC, oops. And by the way, before this, let me make sure I have auto formatting. So save actions. Okay, I'm just gonna apply all this stuff so it automatically format my files. So if MSVC, then I'm going to go with target compile options and source private. So if it's MSVC, I'm gonna go with the W4. If you want to go crazy, you could go with /w all, but this is so annoying, but we're gonna try. Yes. Slash, you could also add SDL if you want maximum security, I guess. It basically adds some security stuff, some security warnings, I believe, and some security checks, actually. And there's also another thing, which is /extern. This would basically disable warnings from external headers. For example, when we're going to, let's say, include vulkan.hpp, it's going to have a lot of warnings, you know, and we don't want to change the Vulkan header, you know, or the external headers. So we don't care about the warnings of external headers. That's why there is a flag for extern. So you just say extern, and here I'm gonna tell it angle brackets. So basically, if anything I include with angle brackets, it will disable warnings for it. And by the way, I don't need this guy. Okay. All right. And of course, after that, you have to make sure to set the warning level for the extern. I believe extern W, I'm going to go with W2 for now. For the warning level. So basically, for my own code, I'm going to go with W4, W all. But for extern, I'm going to go with W2 for now. Can you move your camera to the bottom? It is covering some of the script. Oh, okay. Thanks for mentioning that. All right, let's go. Thanks for mentioning that. All right, so now else, we're going to, otherwise, if it's not MSVC, then we're gonna do target compile options, source private. I'm gonna go with -w all, -w extra, -w pedantic. This is not necessarily the last kind of settings or configuration that we're gonna go with. This will, like, all of this stuff may revolve as the project goes forward, if it goes forward. So anyways, -w all, -w extra, -w pedantic. This is all for warnings. And I believe maybe there is some way to do something similar to extern in here, but I'm not really, I don't know. Actually, I did try one flag, but it didn't really work as expected. So I guess this is what we're gonna go with for now. We may add some more warnings later on, or remove some warnings, depends on the project. But anyway, there's also, you could add slash, I believe, fsanitize equal address. This is to turn on the sanitizer, which would help you catch bugs like pointer bugs, etc. But anyway, I'm not sure if I can use the sanitizer in Clank. Last time I tried, I failed horribly. And in fact, even in SVC, I had to add the Visual Studio kind of directory. Like, there was some stupid, strange stuff to actually allow sanitization in Windows, at least. In Linux, probably it's very, very easy. But whatever, for now, I'm just gonna stick with this. Alright, well, let's see what's gonna happen next. Let's try to compile this. Flow control statements are not properly nested. Did I miss something? Private rebuilding are not properly nested. What do you mean by properly nested, bruh? Let me reload CMake possibly. Really? If MSVC, bro, what? What the? This never have happened to me. If I don't think this way, something is stupidly wrong. Oh, and if, oops, and if, oh my god, gotcha. Okay, let's try it now. Let's go. Okay, so right now, as you can see, this at least compiles successfully with Clank. Now let's try the other guy for a second. Okay, well, how do we get to do that? CMake, right? So let's look for CMake again. Let's switch very quickly to Visual Studio just to have a look. I do remember there was some warnings on iStream, but I don't think I need it in this case. Ignoring a known option. What? It doesn't know extern? Are you kidding? What? Ignoring a known option. Let me have a look. Hold on a second. Let me have a look. Okay, let me grab a browser. Okay, and let's look for extern. Oh, actually I don't need it. Let's just go here. Okay, so MSVC external. Oh, did I misspelled it? Yes, it should be external. Okay, external W2. Let's go. Warnings are very, very useful when it comes to C++. So yeah, pretty much it seems to be compiling successfully, which is nice. Let's check real quick MinGW, which is the equivalent to GCC in Windows. Let's see. And it also builds there correctly. All right, so for now, I'm just gonna go, I believe, with Visual Studio, I guess. Or actually, let's go with Clank. although I'm not sure if Clank debugging is good. Yeah, I don't think it is good, so I may switch to MSVC later on. But anyway, so apparently to include libraries without having warnings from them, use the iSystem flag instead of the... Yeah, I tried that flag, but it didn't really care about it, really. At least that's what I remember, but whatever. Let's just add it, who knows. So dash iSystem. Okay, so now let's go ahead and basically git. So create git repository. Amazing. So we have initialized our git repo. Let's add all the files. I'm also going to add my IDE files. So if you have C-line and you're working with C-line, you know, you're just gonna have all the settings ready for you, basically at that point. So I'm just gonna add all of them. Add to VCS. Control Alt A. Okay, amazing. Now we gotta add some git submodules. Okay. So how are we gonna do with that? Well, let's go inside of third party first of all. So cd third party, change directory to third party. Now we're gonna look for our stuff. First of all, I'd like to get the Vulcan headers. Now, if you are Linux, for example, you could probably just say, or if you are Windows and you have Vulcan header files in your path, you could probably just go directly. You don't need to do this. You could just go directly and include Vulcan. But that wouldn't work for everyone, especially the ones that doesn't have the Vulcan SDK, for example, and or doesn't have them in the path for whatever reason. So just to keep my project as portable as possible and also system independent, I'm just gonna go with Vulcan headers. I'm gonna include that into my project source. So we're gonna say git add submodule, and that also means that I'm not gonna basically depend on my systems headers. I'm going to depend directly on the latest version of the header, Vulcan headers. So yeah, so git add submodule Vulcan headers. Of course, make sure you are inside the third-party folder. Oops, git submodule add, not git add submodule. By the way, I did also try to go with Win32 XCB to create like a raw window, etc. It was fun, but I'm not gonna go with it in this kind of projects for now. So yeah, I'm going to try to stay as modern and portable as possible in this project, hopefully, but we'll see how it goes. I don't have a lot of plans. I'm just experimenting with you, live stream, you know. So that's the Vulcan headers. Next up, I'd like a windowing library. Now there's three main options for windowing, or in fact there is 4 main windowing options. You could either go with the raw API, like Win32 for Windows. You have to make Java files or use the NDK for Android. You have to use like Mac OS have its own API too, you know, and Linux you could use XDB or X11 or both. Or Wayland even. There's a lot of craziness, but that's very hardcore and not very portable and adds a lot of burden or your maintenance, and you could easily get it wrong. Okay, so we still have like 3 options available, which is SFML, SDL, and GFW. Now let's go step by step. First of all, SFML, it's a C++ windowing library, which is interesting, but I don't see it very supported. And also, it still uses like open, like, you know, non-modern OpenGL. What is it even called? I think compatibility OpenGL, right? And it's going through some very big upgrades kind of right now. And also it's not very geared towards Vulkan. It's very opinionated kind of thing. But basically I don't like SFML currently. Maybe later, who knows. Now we still have SDL and GFW. Now, the problem with GFW is that it's very geared towards OpenGL too, although you could perfectly use it with Vulkan. In fact, it's very, very good. But The caveat and the big problem with GFW is that it only supports desktop platforms, okay? But on the other hand, SDL supports a lot of platforms, including Android, iOS, a lot of craziness, okay? And it also is, while GFW only gives you the windowing and the input, basically, and gives you some Vulcan wrapper stuff, but SDL gives you like a whole cross-platform layer on top of the OS, on top of the operating system. So you can really basically abstract your code and your systems from the operating system at all. Like anything that relates to the operating system, you can rely on SDL, which is quite interesting. But the only problem right now with SDL is that, first of all, it's a C API, so it's not very ergonomic for C++. But that's not a big problem. The second thing is that right now they're upgrading to SDL3, and so we're gonna have like it's gonna be breaking a lot of compatibility stuff, and it's gonna have a lot of upgrades. But we don't care. We're just gonna go with SDL. It's the only real sane option. You could go with SDL2, you know, but you know, like if you're really serious about your project and you're looking for the long term, you know, like once you finish your project, for example, or you know, you reach some respectable state, especially using Vulkan, you're gonna find yourself like you're gonna find SDL2 like they just buried it, you know. But whatever, I just prefer to use SDL3 directly, although we're probably gonna have some hard times when there is some breaking changes, which is gonna be expected because we're gonna not be using a release, we're gonna be using the Git repo directly. But whatever, I only did GFW, so I'm interested in how to manage others. Yeah, it's gonna be very interesting. And in fact, even GFW and SDL, whatever, a lot of people get it wrong. But you'll see where they get it wrong. Although I'm not sure if it really, but whatever, we'll see. Git submodule. I did learn a lot about how that stuff works when I learned about Win32 API, XCV. I also implemented in Zig. I implemented dynamic library stuff, and also learned a bit of Unix functions, etc. But whatever. Anyway, get submodule, add SDL, and right now we have Vulcan headers and SDL, but we gotta integrate them. We gotta integrate them into our project. So here it is very easy once you get your initial setup ready to add a new library. That's what's very nice about CMake. Okay, hold on a second, view files. Okay, add. So here's how you do it. Basically, you gotta add the subdirectory that you want. In this case, I'm gonna add the Vulcan headers. I'm also gonna add the Vulcan, SDL, okay? So first of all, you add the subdirectories that you want. Next up, you link the libraries. Okay, of course, by the way, there is a lot of ways to work with CMake, to set up CMake, but here I'm showing you the most modern way of doing it, which is the best way currently, I believe. But anyway, target link libraries. So you're gonna link third party. You're gonna use interface, and here right now I can link my libraries. I'm gonna link Vulcan headers. And by the way, I know these names by actually reading through the source code of the CMake file. Like if you look here, you're gonna find the target. As you can see, there's an add library, target, Vulcan headers, etc. Whatever. There's also an alias. You could also use Vulcan-headers, but I don't like aliases that much. So Vulcan headers, I'm also gonna add SDL3. Oops, what I'm doing. SDL3, SDL3. Same thing with CMake of SDL. Now SDL by default links dynamically, which is like there is some stupid error with it currently. I don't know, like I basically have to change the directory of the dynamic library produced by SDL, at least in MSVC, so there is some portability issue there, which is not very nice. So I'd probably go with static linking, but let's just see 1 second. Okay, let's try to build. Okay, right now, as you can see, it's building SDL. And the other nice thing about having the whole source code in your own project using the submodule is the fact that you can at any time look up the source code of that project, and even in your IDE you can, for example, hold control and click, and it may take you into the source code, especially when it comes to debugging, you know. And also the other thing is the fact that using CMake, it will automatically like builds SDL for debug or release depending on which configuration you are in. There's a lot of beautiful things about this setup. So yeah, that's why I'm going with it. So as you can see, there's no problem with this, but if you go with MSVC, I believe there was a problem with it. But just to make sure we're sane, I'm just gonna delete the build directory. I'm gonna first of all stop the CMake stuff, and I'm going to remove the build directory, and I'm going to reload CMake, and let's see if it works with MSVC. Basically, I think MSVC puts the dynamic libraries in another directory, so that's making a problem. But I'd rather just avoid all these stupid problems by just static linking for now, at least. So yeah. And it also results in me only having to, like, it will produce a whole binary. I don't need to ship with it and DLL, etc. Although dynamic linking with SDL is probably better for production, but whatever. Okay, let's try this now with MSVC. Okay, it's building. Well, hold on. I need to actually include, first of all, SDL right now. So, oops, SDL.h, let's go. Now you basically say SDL init, SDL init flags, SDL init video. Now, whenever you use an SDL, I just rather make sure that I'm getting the signature right, just in case. Char. I think this is required for SDL2. I'm not sure about SDL3, probably not. But anyway, argv. So yeah, int argc char argv. Okay, amazing. Now SDL init. Now let's try this up if this actually works. There you go. As you can see, the code execution cannot proceed because SDL3.dll was not found. Reinstalling the program may fix this problem. Now, instead of having all these stupid problems, I'm just going to add a flag. And I don't even remember what this flag is. Hold on a second. CMake build shared libs. Okay, there you go. I always forget about this simple flag. So here in my CMake options, if you're using CMake through command line, you have to actually add this to your command line while generating CMake stuff. So here -d, basically I'm defining build shared libs to equal to off. So any library in my CMake stuff will hopefully build statically instead of dynamically, including SDL. And okay, right now it's gonna load CMake from scratch again. Now as you can see, build well, what? Why build static? I think it just have to reload it. I'm not sure why it's saying on and off, but I guess this should work fine. Okay, that's gonna be interesting. Let's wait for CMake to load in. I'm probably going to debloat SDL later on, but right now it's fine. There's a lot of flags that you could tweak. Basically, for example, we don't need the SDL renderer. We don't need a lot of stupid stuff in SDL that we could basically get rid of, while you couldn't easily do that if you're not using CMake. But since we have the source code and we're building from source code, that's very, very easy. Now this is working just fine, as you can see. Which is amazing. Now let's try real quick Clank. Real quick. It's gotta reload the whole project once again. Oh my god. So, okay. As you can see, it's building from source. What's going on here? I think I have to probably remove the build folder once again. It's probably conflicting. Reload. Oh my god. Now I gotta get a coffee. And wait for it to reload again. If there's any questions, let me know. Hello, Zafiel. Welcome to the live stream. Very cool, indeed very cool. All right, amazing stuff. Okay, seems all good. Clank 2 works great. Now let me just make sure debugging is right, okay, with Clank, because last time I tried it didn't work well. Well, it didn't work for C-Line for some reason. Not sure why or how to fix it. So sadly, unfortunately, we're gonna go with Visual Studio MSVC. So yeah. We could still go with Clank for release builds, but well, whatever. Okay. Right, for now we're just gonna go with Clank because, sorry, MSVC, because debugging doesn't seem to work with Clank for some reason. So the nice thing about MSVC that I really like about MSVC is they always stay on the bleeding edge. So if you like to use the latest C++ features, for example, then you'd probably love MSVC. The MSVC SDL library is like really the latest thing in the market currently, I think. But anyway, updating symbols. If I were using the command line instead of an IDE, I would have probably still going crazy with my commands. And anyway, imagine doing this stuff in Vim. I do not have that experience. Okay, let's go. All right, so as you can see, debugging works with MSVC, and this is that guy. Right now, I could basically go inside, look into what SDL is doing since I have the source code in my project. My CPU, I don't know my CPU. Let me have a look. Okay, where is it? This PC properties. Okay, there you go. It's Intel Core TM i5 10400F CPU, 2.90 gigahertz, 2.90 gigahertz, and the 24 gigs of RAM, DDR4. So in fact, it's better if I show you the actual task manager, really. Task manager, let me go to performance, CPU. Okay, there you go. So I have basically one socket, 6 cores, 12 logical processors, virtualization is enabled, L1 cache 384 kilobytes, L2 cache 1.5 megabytes, L3 cache 12 megabytes, and this is the processes, threads, and handles, which you would only understand if you tried Win32 API, but whatever. Okay, so that's the craziest stuff. All right, amazing. Now, as you can see, since I have SDL in my own source code stuff. Oh, welcome Marty Flowers. Welcome to the live stream. Since I have SDL in my project, like the source code, now I can actually see what SDL is exactly doing each and every step, and I can see every variable what is going on. It's crazy. So all of this happens in SDL init, as you can see. Crazy stuff. As you can see here, it's I think loading the SDL procedures from the dynamic library, etc. But you got the point, as you can see. So that's very, very interesting. But anyway, right now we actually have to do SDL quit. Now, the problem with using a C API is that when you have initialization and de-initialization stuff, having source is overpowered. Yeah, it's very, very amazing having a source code in your project, especially in debug stuff and whatever. Anyway, so also it optimizes better in release mode if you're using statically linked stuff, I guess. So right now we're using static linking, but yeah. Now the problem with doing this way, the raw C way, is that every time you want to return early or to throw an exception, you have to make sure to quit correctly. So for example, if I want to throw some kind of exception, let's say some runtime error, for example, hello. Okay, now the problem that's gonna happen is that I'm not gonna quit correctly. It's just gonna stop, like go out of the function, and there you go, I have a memory leak or whatever, or some crazy stuff. So I better off use raii to make sure whenever there is an exception or I quit a function early or whatever happens, the destructor is called gracefully. So we're gonna wrap all the C API stuff in raii classes. But a disclaimer, I'm still really learning C++. I'm reading a book currently. It's like around 1,300 pages of codes, and I just finished the basics of the basics. So it's crazy. I thought I was actually knowing C++, but when I started reading through that book, just the basics, I was like blown away of the details. But C++ is a very, very powerful language, but you could easily get frustrated, hit a train if you don't know what you're doing. But yeah, anyway. But you're not limited to the borrow checker like in Rust or the interpreter in Python and in the GC in Java, Python, or whatever. But anyway, whatever, that's for another video. Anyway, right now I'm just gonna make a class called SDL. I'm gonna create a constructor. Let's go. And I'm going to init here. Here I'm gonna pass the SDL init flags. So flags, init flags, and here we're gonna use it here. Okay, now I'm just gonna get this guy, and right now instead of this I could just say SDL SDL init flags, SDL init video, because I'm only gonna be using the video subsystem, so I don't have to the other nice thing about SDL is that you have audio, you have all sorts of craziness, but for now I'm just going with video. Right, amazing. So I'm gonna make this explicit. Okay, nice. Now I also need a destructor. So, oops, not explicit. SDL, and here I'm gonna SDL quit. Oh, sorry, gotta make sure to make this public. Or I could make this a struct, just like this, and it would be by default public. But just to stay consistent, I'm just gonna go with a class. Okay, whatever. I'd also like to remove the copy stuff, because it could easily ruin your day. You could be doing some copies without even knowing it. So I'm gonna go ahead and look for C++ copy assignment. Okay. Or in fact, if I look into C++ boost library and look for non-copyable, okay, this is a very well made library, but it's very huge. But yeah, so here's the deal. You could just get this guy. Now we could make a class called non-copyable and just inherit from it, but there's no need, honestly. Let's just keep it simple for now, I think. And let's just go SDL, 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 SDL. Okay. What's going on here? What's the problem? I have no idea what's the problem. Oh, equal delete, I believe. So I could delete it. Equal delete. Right? Actually, let me have a look into the source code instead of the HPP, maybe. Just to make sure one little thing. Let's look for GitHub. There you go. Boost, non-copyable. Okay, let's look for that file. There you go, .cpp. But that's the test. Utility, there you go. Let's see real quick what's going on here. What the? That's not what I need. No idea. I guess it's maybe a just header only, right? So for now, this is fine, honestly. Just to make sure I'm not copying that stuff without even thinking about it. So now I don't need to do any SDL quit. Now it's basically going to do that for me automatically since we have a destructor. So basically, let me show you real quick what's going to happen. So, okay, let's see. As you can see, it goes into there and SDL init. And I'm just going to quit from here. And then it will go down. It will reach the end of the function. So what's going to happen then? It will run SDL quit itself. So basically, when it quits the scope, it will destruct automatically. And if some exception happens, that's gonna happen. That's gonna destruct itself, basically automatically. But anyway, whatever. Right now, let's actually initialize the Vulcan library. But for that, we need to include another header. By the way, I don't need IOString, and in fact, I'm probably not gonna use it a lot, but you'll see why in a second. And I cannot do this now. Let's just say 0 for now. And I'm basically gonna have an SDL library, a Vulcan library. And in fact, let me make sure to include SDL vulkan.h. Basically, this header contains some utilities for Vulkan, for dealing with Vulkan from the SDL. So here we're gonna say explicit Vulcan library. Here you're gonna have the path const char path, I believe. It's gonna be null PTR by default. Okay, and here I'm going to say SDL Lloyd Vulcan Lloyd library. Let's go. And here I'm gonna pass in the path. And there you go. Now this could fail. In fact, even SDL init could fail. I forgot. So it can return 0 on success or negative error code on failure. So I'm going to create an SDL exception. And by the way, I was a big hater of exceptions, but while dabbling with with various error handling mechanisms, at the end of the day, I found out that there's just nothing better than exceptions, because error handling is just so complex if you want to do it right. So yeah, and exceptions, just try as much as better as possible. But anyway, whatever. So class SDL exception. By the way, it will actually inherit. I'm not sure if I'd like private or public. I didn't study that yet, but for now I'm just gonna go with private. So private std, I'm gonna go, I believe, with runtime error, possibly. Hold on, I need std accept, so include std accept. This will basically provide me with some built-in exceptions. I'm gonna go with runtime error, and there you go. Now I'm gonna override some functions. Okay, I'm gonna override. I don't need to override the constructor. Just what? Actually, no, I do not need to do that, honestly. I just need a constructor really for now. So SDL exception, and it's gonna take a message, or basically what? So const char message. It's also gonna take an error code. So int code. And I'm gonna have private. Actually, I don't need the private, it's private by default, so I'm just gonna say public here, in fact. And here I'm going to store a const int code, right? And here we're gonna initialize the code to code. And I also need to initialize the runtime error. There you go. I'm going to go with this guy, I believe. Alright, I can either go with this. I'm just gonna go with this guy. And here I could pass in the message, basically. Right. Right. I believe that's it. Maybe. Yeah, I think so. Right? Great. Now I'm also gonna have a getter function, so const int, or I'm just gonna go with auto, why not? Get code, and of course it's gotta be const no accept, since this is just a getter. Return code, no discard attribute, and what else? I don't need the const here since it's an integer, right? Okay, nice, amazing. So what's next now? What's next? Okay, now let's go to SDL init. Now here, what I'm gonna do, and here's a little trick that I learned just recently, which is that you could actually declare variables inside conditions. So here, for example, you could say auto code is equal to SDL init, right? Error code. And basically what I'm gonna do here, so if it's true, basically it's not 0, then we're gonna throw in the SDL exception. And we're gonna give it the message, which is SDL get error. Because if you notice here in the documentation of SDL init, on failure, you can call SDL get error to get a string that describes what the error is. And here I'm just gonna give it the error code. So if we ever need the error code, we can easily get it. So that's pretty much it, right? And also I'm gonna make this equal to 0 by default. Why not? Okay, so that's pretty much it for that one, I believe. I'm gonna do the same exact thing with the other guy, because this SDL Vulcan Library can also fail. So 0 on success or negative error code on failure. Call SDL get error for more information. So we're gonna do the same kind of thing. Just instead of SDL init, I'm gonna do that guy. And I'm just gonna throw an exception with SDL get error and error code. The only problem that I'm kind of worried about is the fact that I think SDL get error just returns a pointer to a temporary. Marty Flowers, programmer as ASMR. Is this a ASMR? I don't know. Retrieve a message about the last error that occurred on the current thread. Okay, it is possible. So one thing about SDL get error is that you should be careful because if you call two functions that can fail, you know, it will override the SDL get error thing, okay? Only the last error is returned. Maybe defaulting code to -1 is more sensible since 0 is success. I'm not sure why I've done this, because later on I'm gonna have some errors, some SDL errors that doesn't necessarily give in code, like it either gives true or false, basically. And I'm not sure what kind of codes SDL could give other than 0. Basically, SDL would give you 0 for success code, and since that code is not being used by SDL at all for error codes, I'm just using it to indicate that there's no real error code get gotten from SDL. Like for example, -1, it could be some indicating some SDL error, you know. But whatever, anyway. I'm not sure really. This is all subject to change at some point. I'm not sure. And as I learn, I'm going to make this code much better, hopefully. As I learn more about C++, Vulkan, whatever. I'm reading a lot of books currently, hopefully. Currently, I'm only really focusing on C++. Because it's such a beast of a language. So, but yeah, I still have a lot to learn. But yeah, anyway. So that's SDL. I'm just making sure to delete the copy constructors and the copy assignments so I don't have any surprises. And other than that, but we could indeed, I'm not sure, but we could indeed say, like, make some class called non-copyable, just like the boost library, and basically would delete the copy stuff, right? So non-copyable. Oops, this should be public. And in fact, can't we just like, I kind of remember like a Rust self function, like self kind of thing. I'm not sure if I can do it in C++. Maybe if I say using self is equal to non-copyable, I guess. And then maybe I could use self. Not sure at all. Would that work? Doesn't seem like. Doesn't seem like it's working out. Yeah, no, it doesn't. That would be nice for copy pasting stuff, but anyway, doesn't seem like it works. So yeah, for now this is fine. Now instead of having to do this every time, we could basically just inherit from non-copyable. We can have like a constructor here, a default constructor, basically. Or equal delete, maybe? No? Nope. Let's just go with default, okay. So that's pretty much it. Now I could basically just inherit from non-copyable and the class will become non-copyable. So that is amazing. I may change that later on, I don't know. But yeah, there you go. That is nice. What's next? Well, in my Vulcan library here, I would need a destructor. So Vulcan Library. Okay, well, here SDL Vulcan in Lloyd library. There you go. Of course, destructors doesn't have any, it's just void, which makes total sense. But if you're working with something like Win32, like for destroying stuff, it does actually gives you an error, which drives me insane since I'm kind of paranoid about warnings and errors, but whatever. So now we could basically say Vulcan Library. Vulcan Library. Okay, what's going on here? What's wrong? Oops, I need public. There you go. And that's pretty much it, hopefully. Yeah, I don't need, by the way, the braces here since I have one statement after that. Save some typing. Right. Yeah, that's pretty much it, I believe. Now, one thing that I would like to know more about here. Now, basically, if you give it null PTR for path in SDL Vulcan Lloyd library, it will basically take care of trying to get a name. Like, it have some default names, but if you have some custom path name that you know of for some certain platform, for example, you could basically say Vulcan Library and then give it the path. But if you just want the default path, then go with null PTR, which I'm gonna do right here. So yeah, we'll attempt to find the vacate instance proc ADDR address. As you can see, this is the default ones, seems like, for every platform. I don't know what I wanted. Oh yeah, 0 and 6s or negative. Okay, nice. Now, one thing that I've said about that I'm worried about is SDL get error. Hold on a second. SDL get error. So let's see. Like, why I kind of talked about SDL error, get last error, because sometimes as a beginner you may do something like this, where like if you got an error, let's say for example here in SDL init, after that you would maybe like use message box to display the error, like the SDL message box. Let me show you. To display the error, and you would say something like this. I don't really remember exactly how it goes. Show simple message box, right? You would possibly use this function to, for example, display the error for the user, but the problem is you have just hit yourself in the foot. Why? Because this can return an SDL get error, and if it returns an error, well, you're gonna return you basically override your previous error. So to actually do it correctly, you'd have to make sure to get the error first. How did you learn CMake? What resources did you use? I didn't really find a lot of resources. It just with time and practice, you know, and just seeing some code from time to time about CMake. But I'd like to learn CMake more through some book or something. I don't know. But this is just from repetition and seeing other people's source code, etc., that I learned some tricks along the way. But in fact, it didn't really, like most CMake code that I find in like popular libraries, or they call it starter CMake, stuff like that, it's just like a gigantic kind of code that you don't understand anything. So I just go with the stuff that I understand and leave the rest. And for example, the flags, like the compiler flags too, the same thing. And you know, just from time to time I find some flag and I find it useful and just include it, basically. So yeah, just with time you kind of get a repertoire of stuff. But yeah, here you would say for like get last SDL, get last error. How do you, what the? why there's no, how do you even do it? Oh, SDL get error, sorry. There you go. You would say this and then show the simple message box, basically. So if message box failed, then you wouldn't override your SDL error, your previous error, basically. But anyway, whatever, that's just a note right there. The other thing that I've said about is, let me see. Okay, there you go. This is what I wanted to check. The return string is internally allocated and must not be freed by the application. But the thing is that I'm asking here is, so it says allocated, so I would guess it allocates a new string for everyone. Because the problem, why I'm checking this is if it's actually returning for me a pointer to some internal buffer that it puts the errors in. What's the problem there is if another error happens, you know, and you actually, you know, in this example, in the std exception that we have here in the SDL exception, we're actually storing that message. So if that's right, then what's gonna, well, I guess we could check it. We could check for that, but for now I think it's fine. Who cares? Let's not be so let's not go so crazy for now. It's fine. Okay. Although it might bite me later, but whatever. Non-copyable. Okay, so this is the Vulcan library right now. So I think we're done maybe with SDL, at least for the you know, the initial setup, I guess. So we got an SDL exception, SDL, and Vulcan library. Is that it? Did I miss anything? Oh yeah. So now what I'd like to do, now I'm gonna include the beast, Vulcan HPP. Now just to be really straightforward, I just started using raii for Vulcan, like the HPP header. I always use the raw Vulcan API. So this is very new to me, and I'm actually exploring it with you live. Like I have little to no experience with the raii. I just started checking it today, and I found it very, very amazing, very useful. Of course, after learning more about C++, but we'll explore it together. I never really done anything serious with Vulcan with the HPP header yet, but we're gonna do it together live, and hopefully everything goes right. So bad with raii, but hopefully I'm going to improve, and we'll see how it goes. Wrapping a C# library to C++ is an overhead I'm not enjoying so far. It's not really an overhead. I did have like the same kind of you know, the same kind of mentality, like wrapping some, but in C++, man, it's crazy. Like a lot of abstractions in C++ are just zero cost. So at the end of the day, it may probably just like you wrote the same code manually, but it would be better since you probably have missed a lot of destructor stuff, etc. But whatever. The only thing that have a cost is exceptions. But the thing is, when you come to think about it, actually handling errors correctly, using, for example, something similar like Rust, where you have to return an error and then cascade it back in function calls, basically emulating exceptions, have its own kind of overhead. And in fact, checking every error manually without exceptions and making sure everything is right would require you to write a lot of code, which would lead to very big error prone code, and you constantly have to think about errors, etc., and your code is basically jumbled with error checking code, which is just so annoying. But using exceptions, you have the same kind of thing, but even better. Although it does have a little bit of a cost for what it's doing, but yeah. But basically, what you do with exceptions is that you separate the error handling from where you actually get the errors, basically. But yeah. the error checking from the error handling. So whatever. So now we got the Vulcan library. Now what's next? Now the first thing that you do is you create a context object. So raii context. So there is a lot of ways to use the HPP, the Vulcan HPP header. But the most C++, modern C++ way is using the raii header, you know, which basically kind of wraps everything in its own class with constructor, destructor, etc. Which is very, very amazing, honestly. So yeah, so here you create a context. Let's see, context. And the what is a context? Basically, it goes ahead and it fetches the global function pointers. Like, let me show you. So context dot. Okay, so it fetches from the, well, since I'm not given any Vulcan library here, it will go ahead and by itself load the Vulcan library and loads the function pointers for enumerate instance layer properties, enumerate instance extension properties, enumerate instance version, create instance, and basically these 4 functions, which are not really bound to any instance or device or whatever. These are just the global functions, basically. But in my case, the thing is, I'm already, like, this would be amazing if I wasn't using SDL, since I wouldn't need to load the library myself using system calls, etc., like Win32 load library, etc. I mean, if you check here, you're gonna find that it's doing that stuff. Let me show you. Oh, why it's not? What? Not sure why it doesn't show it here. Maybe it's because the file is so huge that my IDE is broken. But yeah, dynamic loader. But whatever, basically it uses DL open and load library. But in my case, I already have SDL, which does load the Vulcan library for me, so I'm gonna use that. I'm gonna tell it to use that. But before I can do that, I need to actually Vulcan HPP enable dynamic loader tool. So yeah, there you go. So this guy. So I gotta disable this guy because I want my own kind of thing. So before including the raii header, I'm gonna define this to equal to 0. So it wouldn't do the loading itself, the library loading itself. I would rely on SDL for that. Personally, I think SDL would probably have a better job at doing that for cross-platform stuff. So Vulcan HPP enable dynamic loader tool 0. Okay, amazing. So now you can notice that it's no longer can be constructed like this. It requires one single argument, which is of type get instance proc addr, basically the get instance proc addr function. But I still don't have that, so I'm gonna make a function here inside of the Vulcan library after the destructor, whatever. And I'm gonna call this get instance proc addr, I think. Okay, const auto get instance proc addr. Whatever. And here we're gonna basically say SDL Vulcan get vacate get instance proc addr. Okay, so this would basically go ahead, it will get the address of the vacate get instance proc addr function from the Vulcan library that we have loaded. This should be called after either calling SDL Vulcan load library, by the way, or creating SDL window, the SDL window flag, Vulcan flag, as you can see. So the thing is, this actually returns SDL function pointer, but we have to cast it ourselves to a PFN pointer function type vacate get instance proc addr. So let's do that. So const auto get instance proc addr is equal to this guy. Now, as you can see, this is const void. I'm going to cast it using reinterpret cast. And I'm going to cast it to, like, to cast function pointers, you have to use reinterpret cast in C++. So, or you could use the C casting kind of thing, but that's kind of dangerous. But yeah, SDL, actually not SDL. In this case, it's vk get proc addr. There you go. PFN vk get instance proc addr. That's the type. And of course, the expression is this guy. Now, this could return null PTR, which means that it have failed to get the procedure address, the function address from the library. Now, by the way, if you have noticed, I can indeed make this function, for example, static, because I'm not using any, in fact, I don't have any member variables in my class, but I'd like to keep it non-static because I basically want to encode in my design of the class that this guy should not be called before actually, you know, constructing a Vulcan library class, you know. So as to keep the invariant basically, but whatever. Now I could basically return it, I believe, but before that I have to check, make sure that it's valid, because this could return a null PTR, so the function pointer for vkk instance proc addr, or null on error. Now you would notice that it doesn't really give us any kind of error, it just basically returns null or the function pointer. So what I'm gonna do here, if get instance, in fact I could just say this, put it here. So if that didn't fail, then we're going to return get instance proc addr. Otherwise though, we're going to throw SDL exception, I guess. I may actually change this to something else, like a runtime exception or something, I'm not sure. But for now, I'm just going to go with that, fine. Yeah. So the message would be couldn't Lloyd vk get instance proc addr function from the Vulcan dynamic library. And here's 0. I don't really have a particular error code in this case. So yeah. Now here I'm going to basically say Vulcan library dot get instance proc addr. Now I'm gonna mark this const, and let's go maybe const here too. It will tell me that it can be made static, but I don't want to do that. So what I'm gonna do is I'm just gonna tell it to kind of disable it, and in fact I'm just gonna take that guy, I'm gonna put it in here. This would basically ignore this error in this case, or that warning, should I say, not error. Should be marked no discard. Okay, there you go. Amazing. I don't need const, right? Yeah, I don't. All right, so that's pretty much it. There you go. Now hopefully we have the context. Now after this we're gonna have a smooth ride, because pretty much, well, not a smooth ride, we still have some stuff to do with SDL later on, but for now I think this is fine. Now we're gonna deal with the vk raii stuff. Now we're gonna find this is really amazing. Let's see how it goes. So auto, let's say API version, for example, or actually let's just call it version, whatever. And now you could basically say, for example, context dot enumerate instance version, for example, and now we could basically say stdc out. Oh, actually let's just use SDL log. Okay, so, and yeah, this is the time to tell you why I'm not gonna probably not use IO stream Instead, I'm going to be using probably SDL log. I'm not sure about this. It may change in the future, but for now, I'm going to be probably using SDL log, log error, log critical, etc. Because it have a lot of pretty interesting stuff, first of all. And second of all, it would make sure to do the right thing in multiple platforms. For example, in Android, I think IOStream doesn't really work. Android is the standard library is minimal, I believe, maybe. So you may not find IOStream, and even if it works, I'm not sure where it really logs. But basically, I'm just gonna use SDL log, and it will try to figure out, since it's a cross-platform thing, it will try to figure out where to print that stuff, whatever it is. Although right now I'm just using this for debugging, but yeah, you got the point. So Vulcan API, or in fact I don't need all that stuff, you know, fine. Vulcan API dot d, and here this is similar to cprintf, so Vulcan API. Okay, what to do now? Yes, vk enumerate. Oops, sorry, no. Version API, version. Actually, API version, I believe, isn't it? Yeah. So I could say API versions major, and then I could pass in the version. Then vk API version minor, pass in the version. Now let's hope this works. Okay. Oh, it's taking forever. There you go. Info Vulcan API 1.3. Let's go. It works. So we're using the SDL loaded library to get a proc address. We're passing it to the context. And then we're using the context to enumerate instance version. And as you can see right now, this is working. Amazing. Now let's have a look into the warnings. Let's see what's going on there. So there's a lot of crazy stuff there. Honestly, this is a lot. If you're annoyed by warnings, you probably want to remove wall. Because it's just so crazy. Messages. Let's see now. Oh yeah, Android really does not have iStream. I told you. So yeah. Warning. Throw in SDL exception to font on considered catch site. Oh yeah, it's telling me about the fact that I'm not actually handling it right now. Runtime error, this base class is inaccessible. What? I feel like warnings will just slow us down a lot, since we're doing a lot of unsafe stuff. Oh man. So for now, I guess I'm just gonna go with the lower one until later on. I don't wanna deal with warnings for now. So we could basically progress in the project quickly. Since we still have a lot to do, than trying to fix every warning. And for this, well, you know what? Let's just do W2. Let's hope that works. Right, W2. Really, it still does give me that warning? Yes, it does. So I'm gonna do just W3, and I'm just gonna disable this explicitly. So I could say /WD and pass in that error code, and it would ignore it. I could also add WX and -W error, but that's very annoying, since it wouldn't let you compile at all until it fixes all warnings. which may be good later on, but for now I just like to really quickly, hopefully, implement stuff. So yeah. Okay, so right now we're all good to go. Now let's start by creating the instance, right? But before that, you probably would like to get the SDL, the Vulcan SDK. So you just go here, and download the Vulcan SDK. And depending on which platform you go with, like if you have Windows, click on Windows. If you have Mac, go with Mac, etc., whatever. And Linux, there you go. Android, but whatever. For example, here is Windows. You just install the SDK and just next, pretty much. There is one option in Windows, at least, that you basically, it tells you some components, which components you would like to install. Personally, I just selected all of them just to make sure I didn't miss anything. But it's your choice to do whatever you want. So yeah, that's pretty much it for that. Other than that, now that would provide you with some tools, like some really useful tools like vkconfig. And vkconfig basically shows you the layers, like validation, API dump, rate capture, physical device selection, portability, blah, 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 whatever. In my case, let's go maybe with API dump, for example. And let's try to run the project. It doesn't really tell me the API dump for some reason. But what if I... Hold on a second, debug. So let's say, oops, let's go back and let's say build slash debug slash, what is it even called? Trying to find the executable. There you go, it's inside source. So source slash source.exe. And it still doesn't really do that. It did work for me in Linux. I'm not sure it doesn't work here. But what we could do for now, we could just give it the... I'm going to copy the path. Absolute path. I'm going to pass it here, hopefully. And let's hope for the best. The working directory is, well, I'm just going to pass to it the project's root. And command line args, I don't know about that. Nothing, I'd guess. And output log, I'm going to go with that slash Vulcan config log.txt. Okay, there you go. Now let's try to launch this, hopefully. And let's see what's gonna happen. Okay, so it's good telling us that info. But why it doesn't dump the API? That's stupid. Weird. And we do indeed have the Vulcan config log, as you can see here. But I'm honestly gonna ignore it from Vulcan config log from Git, basically. Okay, now why this doesn't work? That's the real deal. API dump. Not sure why it doesn't work. That's stupid. And sorry for blinding your eyes. Synchronization, validation. You can make it cross-platform if you code in JavaScript and put this in the browser. Oh man, don't even say JavaScript. Oh, I hate it. I can't live anymore without static analysis, you know, and zero cost abstraction at this point. Oh man, validation. let's try validation possibly. Let's see what's gonna happen there. Yeah, I would guess we have to do it ourselves. I don't know why Viki config doesn't work out. Stupid stuff. Super weird. But anyway, let's just let's just go forward. Whatever. I don't know why that's the case. I'm gonna try to figure out later. But anyway, right now I don't really need the inversion, honestly. So I'm just gonna go with right now I'm gonna try to make the instance basically. So let's go ahead and do that. So vk raii instance. Now this requires a context, which we already have, and it requires a create info or a vk instance handle. In my case, I'm gonna go with the create info. So, and you could also give it an allocator, but that's optional. Hopefully it's not because of the iSystem flag. Really? Can it be? I don't think. Like, why would that be the case? Actually, in fact, I'm actually using MSVC anyway, so. Oh, what if I used another compiler though? I don't think that's the problem, but I may try it later. Anyway, for now, let's just move forward with our lives. Okay, so vk create info. Well, vk create instance create info. Honestly, instead of create info, just call it info, I guess, or it's fine. Anyway, whatever. Now you could basically pass everything just like you're calling a function call, but that's very unreadable. So like you could basically do it like this and just pass every parameter by itself, you know, but that's, I don't want that. I'm just gonna set the I'm interested into the p application info. So application info, I'm gonna set that to application info. Now of course I have to create the application info first, and yeah, application info. Okay, I'm only interested in one thing in the application info, which is the API version for now, I think. Yeah, and I'm gonna go with the latest. Why not? Although I'm not sure about Android if it supports the latest, but whatever, who cares? For now it's fine. Here we gotta actually pass the reference, not to, or a pointer basically, or whatever that is. Okay, nice. That's the thing with that one. Next up, you would probably like to include the extensions, but of course we gotta get the extensions from the SDL library, since that's platform dependent basically. So we're gonna add another function. I thought we were done with it, but in fact we're not. Okay, let's add here. So auto get instance extensions. And here I'm gonna use SDL Vulcan get instance extensions. Let's go. Now Vulcan is SDL is kind of weird when it comes to getting extensions. Like if you're used to GFW and other APIs, is that it's kind of similar to Vulcan, to the Vulcan API, the raw Vulcan API. But yeah, so here you basically pass in an address to count and null PTR at first, and of course I need the count here. Uint 32t count. Oops, just like that. Right. And then after that, but of course this could fail. Let me see one thing real quick. So SDL true on success, SDL false on error. So if true on success, so if not, then we're gonna throw exception. So SDL exception. Couldn't get instance extensions. Vulcan instance extensions. And we don't have any particular status code. Other than that, we have to basically call the same function once again. Now this one function, what it would do at first, when you pass in null PTR, it will put the count of the extensions in this variable that you pointed to. Basically this is an out parameter, right? And now you have to, after you get the count, you have to basically allocate space to get allocate some space to get the Vulcan extensions, which I'm going to do using std vector. And basically I could say extensions, pass in the count, and it would do the rest for me, hopefully. Oh yeah, I have to tell it which type. It's basically const char, I believe. Oops, like this, I guess. Can I do const like this? I'm not sure. No, I cannot, right? Okay, so that's basically it for that one. Now after allocating space, I have to call again the same function, but this time instead of null PTR, I'm gonna give it the pointer to my allocated space, which I can get from std vector by using the data function. As you can see, it's returning const char pointer. As you can see, now this is extensions count, and this is the actual extensions basically. Now after that, I could return the extensions for vector. And with that, I basically, and by the way, there is some mechanism in C++ that I don't really remember what is it even called, but basically in the extensions vector here will get moved instead of copied. So yeah, now get instance extensions. Now we could pass it up. So how we gonna do it? Well, const auto extensions. By the way, this could be constant. I still didn't get into the habit of making everything constant. Now in Rust, for example, everything is constant by default, and you have to go out of your way to declare it mutable if you want to. And also Rust by default moves stuff, but in C++ by default you have variables, not constants, and by default it copies values instead of moving it. I'm so sleepy, I thought it was an operator. Yeah, it's crazy. Right. By the way, I just figured out while reading a C++ book that you could virtually overload everything you'd like using C++, even the new operator and crazy stuff like that. But yeah, const auto extensions is equal to what now? Vulcan Library, get instance extensions. No. VKRAI. Here, let's actually, should call this instance though. Right. Alright, cool. This is gonna be const, I guess, for now. And yeah, so after getting our extensions, now we could pass it up to create info. Now here, instead of using normal member variables like I've done here and here, if I'd done that, I have to do it like this. Notice. So I have to do count is equal to extensions dot count. right? Oops, what I've done there, no. Dot size, oh yeah. And then create info dot enabled extension names is equal to extensions dot data. I'd have to do it this way, basically passing the count and the raw pointer separately, which is very error prone. But if you use the function call, yeah, you could add you could give it basically an array proxy, which is some function basic, like some class that kind of represents, you could basically pass to it a vector, an array, whatever you'd like. In my case, it's a vector. So yeah, extensions, and there you go. Now I do not have to set the count and the pointer, one by one, which is very, very error prone. Alright, so that's pretty much, I believe, for extensions. Now there is another thing, which is that in macOS, if you want to support macOS, you have to add the enumeration extension and the enumeration bit. Now, you'd usually say ifdef, macOS, etc., whatever, but I kind of personally hate macros. I try to avoid them as much as possible, and thanks to SDL, that is possible to do without macros. I could use SDL get platform, which hopefully doesn't error. Returns that. All right, so it's either some name or unknown. It's probably literal. Okay, now if SDL get platform is equal to macOS, as you would notice here, it would give macOS in that case. Let me show you. So it's either going to be Windows, macOS, Linux, iOS, Android, or whatever. There's some other platforms, but that are not shown there. So here I'm going to tell it if it's macOS, then I'm going to do something. The problem here is that this won't actually compare the string, it's the text. No, it won't compare the text. It will actually compare the pointers to the text. So this is not right, but we can make it right if we convert one of them to a string view, right? And or both of them, we could compare, like do that. But yeah, I don't know exactly what would be different if I do make a string view out of this literal or SDL get platform return. But I'd rather do it with the literal because maybe it could optimize it out so it would just become a literal but still have the semantics of comparing the content instead of the pointer. But I don't know, I'm not sure, I don't know. Macro would be my choice, and that is static. Yeah, personally I'd like to hopefully just use the function instead of a macro if possible. So if it's macOS, what I'm gonna do, I'm going to add 2 extensions. So of course this shouldn't be const anymore. I'm going to emplace back. Now there's pushback and emplace back, which are very similar, but as far as my knowledge goes, I think emplace back is more superior. I'm not sure why, don't ask me why. I don't know yet, but yeah, whatever. So the emplace back, although I did actually notice that it's much more ergonomic. For example, if you have a SCD pair, you could easily just, instead of doing A, B, and then wrapping it in these guys, you could just say A, B, and it would just work fine. But whatever. So emplace back, in this case, we're gonna go with the vacay extension. Well, it's called enumerate portability. There you go. Vacay KHR portability enumeration extension name. Let's go. There you go. That's the case. So if it's macOS, then add that guy to the extensions. But I should be careful. I should actually set the extensions. I should call this guy after I'm done with editing my vector, because right here it just actually, it wouldn't, like, it wouldn't magically update the count, you know. The pointer, and even the pointer, it could be different because the vector could reallocate itself after placing another element into it. So you should be careful with this guy. So yeah, after doing your all your edits with the extensions, you can do this. And also another thing, which is if Mac OS, then I'd also like to do another thing, which is to add a flag. So application, no, create info dot flags or equal, and then I'm gonna add the, I don't remember even how I can get that. Instance create info flag bits, maybe. There you go, flag bits. Enumerate portability KHR, let's go. And the other nice thing about Vulcan HPP is that it's type safe. So you get a lot of error checking at compile time instead of at runtime. And sometimes as a UB in the find behavior or a crash or a core dump, whatever you'd like. So yeah, I'd rather get my compile time errors, you know. So that's pretty much it, I believe. But just to be extra careful, I'm just gonna put that guy here, I guess. Oh, but I need the extensions. Okay, pretty cool. Pretty cool. So now hopefully that should be fine. What else? What else? I think right now we're all good to go, I think. Yeah. Let's try and see if if we're gonna get an instance or not. Well, at least if it's gonna compile successfully. Yeah, it runs successfully and compiles successfully. Now let's try to use. Now here's the nice thing about Vulcan HPP raii is the fact that when you get an instance, you can see all the functions that are possible with the instance. So that is amazing for beginners, since you could see all the possible functions. Although there is some functions that are only possible if you create some other objects, basically. But yeah, so in my case here, I could basically say for physical, for const auto reference physical device. And here I'm going to say instance dot enumerate physical devices. And here we could maybe say, and even in the physical device, you have its own functions here, as you can see. Let's look for get properties, okay? And then we can get the name of the device. And there you go. Now, let's use SDL log instead. All right, and here. And by the way, never put something like, for example, if you have a string, don't put it directly into the format. That's very, very dangerous. So always try to put the format in the form, like a string literal in the format place, you know. So yeah, physical device to get properties of the device name. Okay, I think that should be fine. In fact, I don't think I need the new line there. But yeah, now let me have a look if this would work. And yeah, I got an exception. What's going on? It's coming from SDL log for some reason. Oh yeah, I think maybe I know why. Because this doesn't live long enough, maybe? Probably. Let me have a look. Const auto properties. Now that's the problem with with raii is that you should be careful about the lifetime of objects. Otherwise you'd crash or something. Let's hope now that works. And we still have an exception. Oh my god. Alright, well, I guess maybe let's try to make sure to put physical devices in its own thing. That may be a problem. And I honestly prefer the initializer instead of the equal. Let's hope for the best. Oh man. We still having a stupid exception. What's even going on here? Alright, that is amazing. Properties device name. But what is device name though? Hold on a second. Let me try something else other than device name. Let's see, for example, maybe there's also limits, which is interesting. Let's see, for example, maybe max memory allocation count, for example. And of course this would be an integer, I guess. Maybe. Let's see what's gonna happen here. Oh yeah, that works. Maybe I know the issue. Maybe, I'm not sure. Device name. Well, what is device name though? Let me check the API. Hold on a second. Vulcan get device properties. There you go, and there's the device name here. Is an array of vk max physical device name size containing null terminated. Well, not null terminated. So why that didn't work? Weird. Maybe something wrong with SDL log. Let's try stdc out real quick. Std inline. Let's include the CDI real quick. Sorry, iStream. Maybe there is a buffer overrun there for some reason. Okay. And it actually works with, I don't know why it doesn't work with the SDL log. Maybe it's a bug from SDL, I have no idea. But I do remember one thing that I'd like to make sure it is not the problem, which is I'm gonna look for printf string length format. I enjoyed this. I would definitely finish the recording. Good night. Good night, man. Thank you for watching. Okay, so I'm probably gonna try to add like a limit, and in fact maybe let's try to use printf instead and see what's the real problem here, because it should be null terminated. I'm not sure why that's happening like that way. cd printf. Let's see what's gonna happen if I use this guy. Okay, but it's cost. Oh, what the? Hold on. Okay, let's see what's gonna happen here. Oh, okay, I know what's happening here. Okay, so in fact this device name is an array proxy. I have to use .data to actually get the thing. Now, since SDL log isn't type safe, you know, that's why that problem happened. So I believe right now if I say s like this and then add in the dot data, make sure to do dot data to extract the row pointer of the string, then this would probably work. Goodbye iString. Now I think why stdc out worked directly, because there's probably they overloaded the O stream kind of thing. So that's why you could basically go ahead and see out device name directly instead of having to say .data. But there you go, now it works. NVIDIA GeForce GTX 1650. That's the only physical device I have. Amazing, perfect. Okay, now one thing that I'd like to make sure, do we really need to do it this way, or is it fine just like that? Same thing here maybe. Since I still didn't really study very well RAIs, I still have some problems with the lifetimes, etc. But there you go, this seems fine. But yeah, but what we really need right now is we need the Q family properties. So let's go ahead and do that. So physical device, okay, Q family properties or something like that. Yeah, there you go. And next we're gonna look for, I think we gotta loop through this guy, maybe. Probably, yeah. Q family properties. There you go. Now let's try to see what's going on here. Okay, SDL log. Not sure where I'd like to log yet, but let's see. Q family properties. Let's go. Let's see what we have. We have Q flags and Q count. Let's see how much Q counts I have. Now let's run this and let's see. And we have a little stupid exception again. I probably missed something there. What is Q count? What the type of Q count is? Oh my god. I think maybe it's some sort of an object by its own. I don't know. Oh, my man, that's stupid. I forgot to make it the. That's what's problematic about SDL log, is the fact that it's not type safe. So you just get an exception or whatever, or a crash when something goes wrong. So I gotta be careful. But there you go. Now for the first Q family, I have 16 Qs. For the second, 2, third, 8, and the other one. Now, if you don't know, there is a beautiful tool called vk. I don't even remember what is it even called. But if I'm just gonna go to the Vulcan SDK real quick. Hold on a second. I'm not even sure where the Vulcan SDK is. There you go. Okay, so here's the Vulcan SDK. If you go to bin, I believe there's a lot of crazy tools right here. There you go, Vulcan Caps Viewer. It's called Vulcan Caps Viewer, and there you go. Now, this application actually shows you a lot of stuff, and sorry for blinding you. This shows you a lot of stuff about like basically all the stats about your physical devices, etc. for Vulkan. For example, right now I was actually looking into Q families in my C++ code, and there you go. So I have 4 Q families, which is right, just like I've seen in my code, and the first key family, it have 16 queues, the second have 2, the third have 8, and the fourth have 1. Now I'm not gonna go into details on what everything does. I already did in my previous tutorials about Vulkan, and right now I'm not really intending this to be a real tutorial, but yeah, for now just gonna go forward. Okay, now the problem here is that I need an index, and to be able to do that I gotta use a raw for loop. Now I could use ranges in C++23, but it's not really that supported. And in fact, I have a problem with C-line. It tells me that there is a syntax error while there's not, but I'm just gonna go with the raw way of doing it. But you could use zip or even better enumerate, but it's not actually supported by any compiler currently, even MSPC. But yeah, whatever, who cares. Now let's get the key family properties, and I'm gonna go with the indexed for loop. Oops, yeah, indexed for loop. And now I0, well, I'm gonna call this something meaningful. Key family index oops. I'd prefer not equal instead of less than, not equal to. Now you may be tempted to say that that's very dangerous, because you could somehow add 2 to the I instead of 1, and then you'll have well, an infinite loop, although it's not necessarily an infinite loop, because it's gonna basically once it reaches the limit of an integer, it's gonna go back, and it would be true at some point, so it's not really gonna be an infinite loop, but you got the point. But you shouldn't have such a thing in the first place, so at least I would detect such a problem, because you have more problems if that happens other than this. So but yeah, not equal to what? To key family properties. Now of course, never use int for indexing into an array, and for sizes use size t or std size t. Better up go with std size t. Or if you feel really adventurous, then what you could do, you could go with I believe like std vector, or you could, hold on, I believe maybe decal type, not sure, let's see. Yeah, and size, yeah, size type. You could go crazy, you could get the type of your variable and get the size type of it, but no, there's no need for this, you know. Just say std size t and say not equal to here key family properties dot size, I believe. There you go. And of course key family index plus plus. And better get into a habit of using plus plus. While it doesn't matter for an integer, but if you don't make it a habit, then you could use you know, x plus plus instead of plus plus x in an object that would make a difference. For example, an iterator, plus plus iterator and iterator plus plus is not the same thing. So but really what we mean here is key family index is equal to key family index plus 1 or plus equal 1, and that's not the same as key family index plus plus. This would actually make a temporary etc, whatever. I don't want to go into details, but the actual equivalent code is this guy, the prefix, but whatever, that's just something to keep in mind. All right, so that's nice. Now we actually have the key family index. Now we could get the key family property. How are we going to do that? Well, const auto key family pro. Actually, I'm going to call this families properties, whatever. and this one, key family properties, is equal to, oops, I think it's probably families like this. Yeah, maybe. Whatever. Now, key family properties is equal to key family properties and get the index. So key family, oops, is key family index. Let's go. And there you go. Use range-based for loop instead. But what about the index? Yeah, because it didn't see me use the index yet. That's why it told me that. But in fact, I'm going to be using it right now. So yeah. Now, we're basically going to have a queue family. So I'm just going to use a using queue family is equal to std pair. It's going to be a pair of std I think just to be, maybe I need vkraii physical device, or I may just store an index, I'm not sure, but yeah, fine. So yeah, just basically making an alias there, so it's much more readable. Now const, and also I'm gonna make it optional. In fact, not const. So std optional. So I may find it, I may not find it, depends. So optional key family. And by default it would be null ptr, and just to be explicit about its default construction there. And now if I find it, then I'm gonna say key family is equal to the physical device possibly, and then the key family index. There you go. Maybe I don't need that, I don't know. No, I need that. Okay, amazing. Now I could check if I found it or not. So if key family has value, then I could basically say SDL log, and then I could, for example, say SD. Then I could basically say key family, hopefully, dot get property. Oh, key family dot first. But I can maybe use the, yeah, maybe, hold on a second. I could basically say auto. So this is a new feature, I believe, maybe C++20, I'm not sure. But you could basically say this, physical device, comma key family index, okay, is equal to key family. And I'm not gonna dereference this because I'm sure that there is a value inside of that, so this is fine. Okay. Now I could basically say physical device dot get properties dot name, comma. Now probably get properties is expensive. I don't think they're caching it, and in fact if they cache it they're probably wrong. But so if you really want to use this, then you probably want to cache get properties for a second there until you get all your properties, instead of just like, it's not like a getter function. But whatever, anyway. Here, key family index. Okay, let's see if it's gonna find a suitable key family or not. Oh, yeah, I've probably done something wrong again. Yeah, device name dot data. And by the way, what I actually done here? Hold on, what? Hold on a second. In fact, no. I should check what I want to check first. So if so if Q family properties, I gotta check for graphics. So if Q family properties dot Q flags, type inference with type hints reminds me of Python. Yeah, there is type hints. It's very, very useful. Especially in the sense that, especially for like big types, and also for like if you want to refactor your code, you do not have to like change the type million times, you know. Every time you use it, you just, you know, change it in one place and then it automatically get inferred in other places. Now that could be good or bad depending on how you look into it, but yeah. Honestly, personally, I like it. So especially coming from Rust, you know, where you have let that equal to that. But yeah, anyway, so Q flags, and it's especially useful because in C++ you could have really, really large names, you know, for types, especially if we're working with something like iterators and ranges and views and stuff like that. But yeah, so Q flags, and I'm gonna look for vacay Q flag bits. I'm gonna look for graphics. I'm not sure if there is a better way to check for Q flags. Like as I said, I still don't know all of the tricks of the HPP header. I still first time, well, I maybe second time to use it, but I never really used it like extensively or for a serious project. But we're doing it right now, hopefully. So if graphics, so it should contain graphics basically. And also, is there anything else that I'd like? Hold on. No, I only care about graphics for me in my case. So yeah, so if it is capable of graphics, then we're gonna make it like we're gonna turn the optional from null to something, you know. So yeah, it's most of the time it's gonna select the first key family because that's most of the time it's the one that supports graphics and all sorts of stuff. But there you go, found key family NVIDIA GeForce GTX 1650, that's the physical device, and the key family index is 0. Basically the first key family supports graphics, and in fact that's true if you look into the vacay caps viewer. But yeah, that's pretty much it. Now we also want to check for presentation, for presentation support, but to do that I should actually first of all create a window, an SDL window, an SDL surface, and a vacay surface from it. Alright, so we probably have to do that now, although it doesn't really matter. In most cases the first Q family with graphics supports presentation, I guess, but we just better be safe than sorry, and I'm just gonna try to do that. Now there is another thing that you have to know, is the fact that you can in fact check for presentation support without creating a window, without creating a surface. But the problem with that is that SDL doesn't give that yet, so you have to do it yourself using some platform dependent functions. I don't know, I don't really remember the name exactly, but it was something like, yeah, there you go. For example, for XCB, which is a window in API, well, not API, you know, it's I don't know, it's complicated, you know. When it comes to Linux, it's complicated what you name things. I don't remember exactly, but anyway, whatever. It's something to deal with windowing, right? So you have to use that for this one. And you only have to pass for the physical device, the key family index, the connection, which is relative to XCB connection, and then the visual ID. So yeah. And if you want for other platforms you have to look for other functions, you know, so we cannot really do that now. Now in SDL there is a beautiful function called SWM info, but the problem I found with this function is the fact that there you go, this is the function. The problem I found with this function is that it requires a window. Now if I'm going to have a window, I could just use the actual, you know, surface function that you use with the Vulkan. I do not have to worry about this. Although there's one little difference between using the Vulkan surface support presentation check and using this guy, is the fact that you do not have to create a Vulkan surface first to use this function. But on the other hand, you have to do some crazy platform dependent stuff with this one to actually do that stuff correctly. So let me show you the struct. Okay, so you basically, when you get the struct, you get the subsystem, which is this guy. It's an enum. So in known Windows X11 DirectXP. Now depending on which platform, you would like to get one of these guys and pass them to the correct Vulkan function to check for presentation support. But why bother, you know? For now, sadly, let's just first of all create a window. But it would be amazing to not have to create a window and a Vulkan surface to check for presentation support later on. So yeah, whatever. Anyway, let's just try to create a surface. And in fact, I didn't create a surface before. I'm not even sure how to do that yet. Vacate raii. How to do this? Well, I would get surface khr. Surface. By the way, how much is the time? Yeah, I have to go soon, but yeah, anyway. In fact, no, I need first of all the window. Oh my god. And in fact, SDL would help us to create the surface, so yeah, that makes sense. But hold on, what it requires though? I'm interested into knowing what it requires first, because the HPP header is quite interesting. So you can either give it a handle that you made yourself, the Vulkan handle, or a vacate display surface create info, or a headless surface create info. So no, I gotta create that guy. Anyway, so right now we gotta create an SDL window. So let's do that. SDL window class. Right. And by the way, one thing, instead of this, but I'm gonna change that later. Anyway, for now, let's just focus on creating a window. So public. Now, first of all, it's gonna have an SDL window, I believe. If I remember, it's a pointer, right? And then in public scope, I'm gonna have a window. Now, honestly, I do not really require to have like SDL in there. Yeah, let's just remove that prefix. No need for it, honestly. Change to SDL window. Yeah, okay. And I don't require this. All right, amazing. Now we'd probably just need the const char title, and I don't really remember exactly how it is, but so let's see. Create window. You need the title, you need the width, the height, and some flags. Okay, so we have const char title, and by the way, we could indeed go ahead and use a string view. For such case, it's kind of similar, but the problem you risk something here is that a string view doesn't guarantee that your string would be null terminated. That's the problem. Especially if you like substr, like you get a string and then you get a substring from that string. Now it wouldn't be null terminated, and that could easily ruin your day. So I'd rather just get a const char or an std string reference. either way. But I don't know, honestly. I'd rather go with const char for now. Not sure. I may change that later. For now, it's fine. For the width, it's just integer. And for the height, it's just integer. So yeah. And then the flags, which would be by default, I believe, 0. But let's see, first of all, SDL window flags. There you go, nice. Now, you wouldn't find such things as SDL window flags enum and SDL init flags enum class. That's new to SDL, just in SDL 3. I'm not sure if SDL 2 will get that soon, or if it already have it, but last time I checked, it didn't have such things. You'd have to just use the bare raw window flags, using int basically. But yeah, that's just something to keep in mind if you're going to use SDL2 for your own project. But yeah, SDL window flags. And if you really want a stable experience, you're probably better off go with SDL2. But depends. Honestly, for me, I don't care. So yeah, const. Here I'm gonna pass it. Oh, actually, I don't need to call it window. We're already in the context of creation a window, so it does make sense that those flags are for window. So const. Although it doesn't really matter if an integer is const or not, but I just like to always do const if possible. So okay, so I gotta actually create a window now. So window, initialize it with that guy. There you go. Now SDL create window, could error, of course, could fail. So the window that was created or null. On failure, call SDL get error for more information. Nice. But we don't have an error code in this case. So yeah. Now what we're gonna do is, if not window, then we're gonna throw an exception. Throw SDL exception, and here we're gonna pass in the message, which is SDL get error, and we don't have a particular error code in this case. So yeah, that's pretty much it. Now for the deconstructor, which we're basically gonna say SDL destroy window. There you go. Now there is something to keep in mind, by the way, is the fact that you don't really have to call SDL destroy window, etc. Like at the end of the thing, at the end of the application, when you call SDL quit, it will automatically destroy all the SDL stuff. But it's nice to always have that guarantee, and because in fact we don't know really the context of that window. But yeah, whatever. So okay, nice. Now I'm just gonna inherit non-copyable, so I don't get any surprises for now, at least. Later on I may think about how I'm gonna maybe copy, move, etc., but whatever. I just don't want to think about it right now. And yeah, like for example, you could make a copy constructor which basically creates a window with the same title, with the same width, height, flags. But yeah, so that's pretty much it, I believe. Right, so let's try to create a window now. I would like a window here before selecting the queue family. With no window, and of course you need title, which gonna be salam. So salam is hello in Arabic. So yeah, const int width. Well, it could also, well, it also means peace, but yeah, whatever. Right. Why it doesn't give me stupid? Okay. The width is, well, let's go with 800, 600, why not? And the window flags, I don't know if I'd like to pass any window flags. Now you would probably want to pass in window Vulcan, but in my case I don't think it matters. You need that flag because basically what happens if you initialize the window with SDL window flag window Vulcan, it would check if you loaded the Vulcan library yet or not. If you didn't, it will make sure to load it first before creating the window. Basically, that's why you need that flag. But since I already have done that explicitly, I don't think I need it. Although it's nice to keep it in there probably, but let's just see if it will work without it, I guess. Let's see what else there is. So you can make it full screen, for example. Otherwise, you'd like to just pass in 0. But you cannot really pass in 0 since it's expecting an enum class. But if you want to really pass in 0, as in my case, then you have to do static cast SDL window flags, right? And then you give it 0 there. So basically you're telling the compiler that I know exactly what I'm doing, just go ahead and do it. Otherwise, instead of having to deal with that weird thing, I can make it a default parameter, because why not? So if you don't specify any particular flags, there you go. Now let's see what's gonna happen here, but let's see. Okay, let's run this. As you can see, it did create a window, but it just basically terminated directly. So we need our while loop thing. So while SDL, I don't even remember, poll event, I think. Yeah, right. Oh, so basically we're gonna have some sort of a boolean. Is, by the way, how much time right now? Yeah, okay, still I have a little bit of time left. Yeah, false. True. While is running. Okay, now basically what I'm gonna do is SDL get loop, sorry, poll event. Then you basically pass it a reference to an event. Now this would return either what? Hold on. This will return 1 if there is a pending event, or 0 if there are none available. So I would just go with the while loop because there isn't necessarily just one event that is waiting to be processed or polled in this case. There could be more, like multiple events. So that's why you have a while, so we could basically pull all the events and handle them in this frame basically, instead of waiting for the next frame to again try to pull one event to handle one event. So yeah, now I'm gonna switch on the event if we have an event. So switch on event dot type, I believe. Okay, now here if it's event type, so if it's event quit, I guess. So in that case, we're going to say is running, or we could call this should close or something. Should close. So while not should close, you could say, and here I don't need to tell it true, I actually can say false like this. Okay, while not should here it should be true. That's pretty much it, I believe. And yeah, and here you basically render your stuff if you would like, or you could render even before input, doesn't matter, depends on your case. So yeah, or to basically scope this to make it more safe, I could use a for loop, right? And then put the guy here and just make sure to add a trailing semicolon there, and that's pretty much it. So yeah, now event wouldn't be basically accessible from the outer scope, which is nice. It's always better to try to initialize, to actually to declare your variable at the place where it's really needed, and also to limit it to the least scope possible, to the smallest scope possible. So yeah. Alright, so this should hopefully work out. I just realized I didn't do this for a long time. Oh, there you go. As you can see, we have a window. It's not resizable by default in SDL3, seems like. But yeah, there you go. Now you could close it like this, and since we are handling the event quit by making should close true, it quits from this event loop, and there you go. Nice. Now we could make it cleaner using some sort of lambdas, you know. There's a lot of stuff that we could do, but yeah, whichever. For now, this is fine. Now we, as you can see, we have a window. Amazing. Now we should use SDL create surface, but honestly I'm gonna do it here. So window. Okay, so here I'm gonna say this probably would return a surface, vacay surface, I guess. Not sure. We'll see how it goes. Create surface. Okay, and let's see how that goes. Create surface. Well, actually, Vulcan create surface. Okay, hold on. Now here you need to pass it the window, which we already have. And honestly, I'd prefer to call this handle instead of window. Just a personal preference though. So yeah. And now here I pass it the handle to the SDL window. And then vacay instance, I'm required to pass in a vacay instance. Now, since I require another object, well, it's fine for now anyway. Later on I may actually create, yeah, that's true. Yeah. Let's actually create another class for surface, maybe. That would probably be a better choice. So class surface. Because why? Basically, I don't want to couple the window to Vulkan stuff. I'd like to keep window, you know, just for SDL basically kind of thing. And class surface could basically go ahead and couple the vacay surface with the SDL window or whatever that is. So yeah, and also I'd like to do more stuff with the surface lifetime, etc. So this is good to go. All right, amazing. All right, so this would store the handle, which is gonna be vacay surface kchar, I believe. Okay, in fact, I'm gonna call it handle, right? Oopsies. Okay, now public. I'm going to go with constructor, and the constructor would require a SDL window and an instance. Oops. Vacay RAI instance. Oopsies. And of course I would pass this by reference, const reference, I guess. Instance, otherwise you'd get a copy. I'm not sure if that's possible, maybe not. But yeah. Okay, and I also need the SDL window, or in this case window, const reference to it. Okay, amazing. Now basically we'll go ahead and call SDL create window. Oops, Vulcan create surface. Okay, and here I'm gonna pass the window handle. So window.getHandle. Here I'm gonna make a getter function. In fact, I can even say const auto here, whatever. Get handle. I could even overload the dereference operator instead, just like how VKRAI does it, I guess. But fine, it's fine for now. Maybe I would do it later. And here we basically are going to return handle, and this would be const no accept. So yeah, no discard, of course. And now let's give it the other parameters, the instance. Okay, so in the case of an instance, we could basically just dereference it to get the underlying vk object or vk instance. And for the surface, this is an out parameter, which would basically give us the handle. All right. No matching function. What? Why? Oh yeah, so I gotta dereference the instance to get the handle, and then reference it again, I believe, maybe. What? Hold on, I'm getting kind of weirded here. Okay, let's see what's happening here. Instance. What that gives me, it says instance, really. Oh yeah, I have to dereference it 2 times because, well, I have a reference, that's why. Yeah, I gotcha. Makes sense. Well, that's kind of crazy, isn't it? Or maybe I don't need that, I just maybe need this. What? Honestly, well, that works better. But why can't just give it that? That's the real question. Really? What? Well, that's fine. I'm gonna call this instance handle. Oh, it has a incomplete type. What? Really? What? Well, does that even matter? Is there like some function to? Good morning, Blue. Welcome to live stream. I'm soon going to end the live stream, but welcome anyway. I don't know. That's super weird. But I guess fine. Let's see if that works actually. Anyway, let's see if that works. So basically, after creating our window, we would create a surface. We would give it an instance. And the window, I believe. There you go. And hopefully that would work. No idea. Well. Vk instance t to vk instance what? Something super weird about this. Alright, well, see declaration of SDL. Well, basically, I think what's the problem here is the fact that SDL have its own definition of vk instance. Well, at least forward declaration, I guess. Use of undefined type. Oh, what? Hold on. No. Do maybe I have to include vulkan.h? I don't think though. But I mean, let's try it. Because it's basically telling me that the declaration is not complete. I'm just gonna make sure one little thing, just making sure. No, that doesn't fix it. Oh well. Let me see 1 second. Vulcan HPP. You know what? I'm gonna take it easy on myself. I'm gonna get this guy so I don't bother with the reference, just to make sure. And I'm gonna say vk okay, surface HR, I guess. No, oops. Window. Oh yeah, gotcha. Instance handle. How do I get the instance handle? Well, by the way, just do this for now. instance dereference that. Oh, shouldn't this be vacay surface kchar? Oh, this is actually a class. Oh my god. But yeah, gotcha. Well, I think I'm doing something a little wrong here. Okay, hold on. Const vacay. But how do I get the actual thing? The raw type. Do I have to like what? Maybe I could just say Vulcan surface. That would be fine. Oh well, that's super weird. Okay, well, let me just include Vulcan for now. I'm not sure. Fine, vacay, no. Proto types, I believe. Hopefully I spelled it right. But anyway. Okay, let's maybe say auto, or actually vacay kchars, or let's just call it s whatever. And oh, this would be vacay result, I guess. Oh yeah, my bad. This would probably give us a enum, no, a SDL true on success or SDL false on error. Okay, so that's how you do it. But isn't it possible with, for example, SDL Vulcan surface? Yeah, it is. Amazing. So, but then I could basically create a surface out of it. Oh, what? Oh, actually, why I even did this, you know? Yeah, it's weird. I did not have to do this. Because we already have a class for that in the HPP thing, right? Yeah, I forgot. So okay, raii surface. Now since I have that guy, I could basically pass in the instance, I believe. And then the raw object, or the raw surface, which is in my case S, called S for now. I guess. Yeah, and then here this is the actual surface. No need for this guy. All right, finally. Oh my god. Like I was just confused a bit there because I have surface gauge R and surface type and all sorts of craziness. So I do not really need to add this guy right now. Okay, amazing. I could just use SDL Vulcan surface type, or I could probably find it in the Vulcan HPP. I just don't know where exactly I could find it. Maybe inside of here. That'd be fine. Doesn't. Oh, I could say C type. Oh, okay. Or maybe I could say native type even. Well, what's the difference between C type and native type though? That's weird. Hold on a second. Why there is both? No idea. But anyway, we're gonna go with this. I didn't knew this existed, so there you go. I learned something new now. So yeah, this is gonna be the surface handle. And in fact, SDL create surface could fail. Could fail. SDL true or SDL false on error. But it doesn't really give us any error. It's just, you know, true or false. That's it. So if not, then we gotta throw. And we could throw just an SDL exception. And the message, let's tell that couldn't create Vulcan surface. And yeah, and honestly, I'm gonna put this guy in the window instead. All right, so how am I gonna do this? Well, create surface. And then hopefully return surface. Now, of course, you do need the instance. So of course a reference. And of course const. I guess. And no discard. Oh, I don't want to do a static. Okay. And so it doesn't bother me with the warnings. I'm just gonna do the same thing as I've done here, because this could indeed be made static, but as I said before, I don't want to do it because I don't want to encode in my design that you do not need an instance to be able to create a window. But yeah, or is it? Hold on, maybe something's wrong. Hold on. Oh my god. Okay, this is actually can't be static. My bad. In fact, we have to pass in the handle here. There you go. That makes sense. Of course, we're dereferencing the instance here to get the raw type, I guess. Maybe in fact I have to dereference it 2 times. Not sure, but this seems to be fine. Yeah. Okay. Now I could basically say const surface equal to window. Oops. Create surface. Here I would pass in the instance. Now, of course, this could also be const, I guess. Not really. Seems like. Actually, I could maybe make this const. Maybe. Yes. Mark no discard. Okay, gotcha. So yeah, that's pretty much it, I believe. Now I think hopefully we gotta create, we got a surface. Maybe. So let's run this and see if it really works. Hopefully it does. There you go, we got an exception. And create surface even. Okay, we got an exception. So, what's wrong? The problem is it doesn't really tell you what's wrong. It just tells you either yes or no. Amazing. Alright. Oh well. The handle is probably fine. Instance surface. The problem with is the fact that create. Oh, actually, since I have the source code, I could just see what's happened wrong, possibly. But hold on a second. Maybe I have to actually do this. Right? Hold on. Maybe that's the problem. Use of undefined type. Well, actually, it's defined. Maybe I gotta tell it myself how it's defined. Native type, right? Hopefully. Don't know what it tried to do there. I guess I should reinterpret cast, maybe. No, it can only be done, I guess, for pointers, maybe. So the problem is Wiki instance T is not defined yet completely. Really. That's super weird. But honestly, I'm just gonna do this, I guess. Well, would this actually work? Hold on. Yeah, it did give the exception. Now, actually, let me just go through it. Hold on a second. Let me go through it. And let's see what's really happening there. Okay. That's what's nice about having the source code. I could basically go through it. There you go. It's checking some window magic. Oh. Oh, gotcha. All right. But in fact, it is setting the error thing. Yeah, but okay, nice, gotcha. There you go. There you go. Now I know the problem. That's what's like. If I didn't have the source code, I would have never figured out why this is wrong. Because when here it doesn't tell me that the fact that it can set an error while it can, because the other stuff it does tell me that. So in fact here I could just say throw and SDL get error basically. That's basically it. And now in fact I'm gonna get the right error. But I don't really know how you're supposed to get the message other than catching it yourself. But either way, that doesn't matter really. Now the problem is the fact that it didn't add the flag, because it's checking if it does have that flag or not. Basically, that's why. So in the window here, I gotta add the flag. So SDL flags, window flags. And then here basically you gotta add Vulcan, SDL window Vulcan flag. And that's why it was erroring. Well, hopefully it works now. Okay. It seems all good. Yeah. Nice. So I would suppose it did successfully did it. So that is amazing. Yeah, very, very nice. In fact, I don't need to. I can just do this, maybe. Okay. And in fact, I just maybe have to pass this guy directly. And I do need this guy. Okay. Let me make sure everything is still working fine. I gotta go real quick, but yeah. Working amazingly. So now let me see if I can really quickly, because I don't have much time left. It's less than 5 minutes. I'm gonna end the stream. So where is it? Oh my god, where is it? Okay, there you go, here. So I don't even remember what it was, what I'd like. Hold on. I believe maybe it's presentation support. Hold on. Physical device presentation. VK physical device present support. Not this guy. Nope. I do not really remember. But anyway, I think so. Right now, I'm just gonna end the stream at this point. It's too late. So yeah, that was an amazing thing. So let's remove that guy. Okay, so that was it for this live stream. We gotta continue. Probably I'm going to live stream tomorrow again, hopefully, and I'm probably going to publish this this repo just after the live stream ends. So yeah, you gotta go for now. Gotta pray the morning prayer. So yeah, goodbye everyone. Thank you for watching and thank you for tuning in, and goodbye.